Good day, everyone. You are welcome to Master Lucas Academy. And today we are going to be looking at what we call thermodynamics, which has to do with CHM 301, physical chemistry. Now, here we go. We want to look at what we call the criterion for spontaneous changes. Now, when we're talking about spontaneous changes, this can be determined based on the value of what we call the change in enthalpy, change in entropy, and a change in what we call free energy. But the most important aspect of it is that it is very, very important to know that the value of delta G must be negative for a reaction or for a process to be spontaneous. So if the value of delta G is not a negative, then such process will not be spontaneous. But be joyous, because I have the simplest method to understand and know whether this particular reaction is going to be spontaneous or it's not going to be spontaneous. So here we go. Join me. Now, if you are very good at geometric and geography, this class will be suitable for you. But if you are not, don't worry about that. Now, we are going to start like this. You first of all draw what we call the cardinal points. Are we together there? Just like the cross, like this. You will now relate this one, this upper region, with the northern people of Nigeria, that is the north. So the northern part of the country, these people that are here, they always observe what we call high temperature. So because of their own weather over there, so you are going to have what we call high temperature in this place. High temperature. I'll be using this short form here. Now you now relate this one that you have here with what we call south. So the people in this region, they always observe what we call low temperature. Low temperature. Low temperature. Okay, you will now relate this particular point here. You know, this is west and this is east. So these people that are living here, they can observe any temperature. Okay, so because of that, it can be all temperature, that is either low or high, or you make use of what we call any temperature. So I'll be using what we call any temperature in this place. Any temperature. Okay, now let us proceed. Now we want to start with what we call spontaneous process. Spontaneous. Okay, spontaneous first. Spontaneous. Spontaneous. That is what we want to start with. Now, for a process to be spontaneous, are you with me? The value of our delta G must be what? Must be negative. So we are going to start with what we call the enthalpy first. So where we have what we call enthalpy change. Enthalpy change. So let this region represent the delta H. Followed by this region, it will be entropy change. Let this place represent what we call delta S. And this region represents what we call the free energy change. So you are going to have delta G in this place. Okay, so you serve all this particular region here with negative. So this one will be negative, this one will also be negative, and this one will also be negative. Okay, now after that, you come to this upper region. This upper region here, you are going to do the same thing with what we have here. So this one will be delta H, while this one here will be delta S, and this one here will be delta G. Now, for each and every one of them there, okay, so if this one is negative, this one will also be what? Negative. Now, why did I say so? The reason being that we are dealing with what we call spontaneous process. So because you are dealing with spontaneous process, that is the expectation. So this is what will happen next. Okay, now let us go in this way. First step. Now, when the delta H is negative, delta S is also negative, and delta G is also negative. Now, the process will be spontaneous for low temperature. Can you see that? Spontaneous for low temperature. Why low temperature? Because the people of the south, they always observe low temperature. Okay, now then come to this particular one here. If this is negative, this one here will be positive, this one here will also be positive. Okay, so let us go. Now, when delta H is positive, delta S is positive, and delta G is negative. Now, the process will be spontaneous at high temperature. Can you see that? Spontaneous at high temperature. So you don't need to cram it at all. Just put everything here as negative. Then put this one as negative, while this one remain positive and positive. So how do you get at any temperature? That one is also simple as well. Now, what we are going to do is you trace this one from here to this region here. Okay, you then trace this one from here to this region here. Now, what have you traced? Precisely speaking, you have traced the value of what? Of delta H. So come to this place, delta H. Your delta H in this place will be what? Will be negative. Now, everything converge and face what? Delta S. That is why I said we need addition of a little bit of what? Of geometric. Okay, so in this place, that means your delta S in this place will be what? Will be positive. Now, the next one there, look at it very well. So it's coming from where? It's coming from delta G. So because it's coming from delta G is also what? Negative. That means delta G is what? Is negative. Look at that. Very simple. Now, what can we say about this? Now, when delta H is negative, delta S is positive, and delta G is negative, then what can we say about that? Spontaneous at any temperature. As simple as that. As simple as that. Now, how do you confirm that the answer you have gotten here is correct? It's very simple to prove. Look at it from here. It will give you what we call right angle triangle. Look at it. If you make right angle triangle with this is what we are going to get at the end of the day. What does that mean? That means for that right angle triangle, delta G is negative in this place. Delta G with this one here is also negative. Then the delta S with this one here is also what? Negative. So because of that, it showcases that you are dealing with what? Spontaneous process, because the value of delta G is what? Is negative. Okay, so this is the way of finding out what we call a spontaneous process. Very simple, reliable method. You can see it is not that hard to understand. You don't need to cram everything on your head. Okay, watch for the next one. We are going to be looking at what we call the non-spontaneous. Stay tuned.